Hello everyone. Today we are going to discuss the very important concept of interquartile range. As we have seen in our previous lecture, the range that is a measure of a dispersion, or a measure of you can say a measure of variability. So it means that as range is used to measure the spread of the data, similarly interquartile range is also used for the same purpose. But what is the difference between the two? First of all, I'll tell you the definition of the interquartile range, and today we are going to discuss very important concepts that are related to this to the interquartile range. So it is defined as interquartile range is used to find the range or width of the middle half of the distribution. We have seen in the range in our previous lecture that range is used to find the width of the entire distribution, but interquartile range, as its name indicates, that it is used to find the width of the middle half of the distribution. Now, how we will decide what is the middle half of the distribution? So for that purpose, we need to consider an important concept here, that is quartile. So in interquartile range, we will make use of the concept of percentile or quartiles. I have already discussed in my previous lecture the concept of percentile, but I didn't discuss about quartiles. So I am going to discuss both these concepts so that you can easily find the interquartile range. So today's lecture is very important in this concern. So another important thing regarding interquartile range is that it is unaffected by the extreme scores, that is outliers. As in case of range, we have seen that if in a data set there is only a single value that lies far away from the rest of the data, it will make the range misleading, because it will not give you the value that actually represent the range of that given data, or that actually represent measure the width of the distribution, or that actually represent the size of the interval over which the data points are distributed. But interquartile range has just removed that issue by using the concept of percentile or quartiles, as we will not consider the extreme scores in the interquartile range. But how? This is very important. So let's discuss these concepts one by one. Keep this in mind. Outliers we have discussed before are the extreme scores. If you have 1, 2, 3, 4, 5 in the data set, and the other score is 100, after 5 you get 100, that is an outlier. That is not according to the series or to the trend of the other data in the given data set. So that it represents the outliers. So this is the main advantage of interquartile range over the range. So this is the main purpose behind the interquartile range. So let's discuss the quartiles or percentage, that how we will just consider the middle half of the distribution to define the range or the size of the interval of the given data set. So in order to find the interquartile range, we have a formula, that is interquartile range is equals to Q3 minus Q1. Now what is Q3 and what is Q1? Q represent the quartile, and Q3 means third quartile, and Q1 is the first quartile. So I'm going to discuss the quartile in detail here so that you can easily find the quartile wherever you need to find the interquartile range. So let's discuss it with the help of the example here. So here we have a data set. You can say this whole rectangle is representing the data set. I'm not going to write any data inside it. It's whatever you can think about it, any data inside it. So here we have one rectangle that is divided into 4 parts. These 4 parts are divided equally. So if I write here that 25% of the data will be here, 25% of the data will be here, 25% of the data will be here, and 25% of the data will be here. It means all the 4 boxes are equally divided. So here what is important is, first we will see the quartiles. So quartile here is in green. I have written in green, so I'll explain it with the green as well. So here, where is the Q1, where is the Q2, and where is the Q3? Quartiles basically divide the data set into quarters. So you can say that it either in quarters, or you can say in 4 equal parts. So if I write here, quartile divide the distribution or the data into quarters or 4 equal parts. So these are 4 equal parts, and if I represent it in terms of quartile, then this lower part will be on the left, and at this line I will say that this is Q1, this is Q2, and this is Q3. It means that quartile divide the given data set into 3 quarters. So first quarter, second quarter, and third quarter. Second quarter is also known as the median of the given data set. So whatever the value of median, it will be equals to the Q2. So in interquartile range, we need not to find Q2. We need Q1 and Q3. So how we will find that? So if I represent here, Q1 is first quartile or 25th percentile. Now don't get confused with the word percentile. I'm going to tell you what is meant by percentile. 25th percentile means that 25% of the data falls below the first quarter, or you can say falls below this, below Q1. 25% of the data falls below Q1. So it is clear here that this 25% data falls below Q1. So this is the 25th percentile. Then we have the Q2. Q2 is the second quartile, and it is also called median, as I already told you, or the 50th percentile. That is 50% of the data falls below it, 50th percentile. So it is clear here that at Q2 we have 50% of the data that falls below Q2. Then we have Q3. Q3 is the third quartile, and it is also called 75th percentile. It means 75% of the data falls below it. And it is also clear here that 75% of the data falls below Q3. So this is the 75th percentile. It is also called in terms of that. So these were Q1, Q2, and Q3. Basically, quartiles are dividing the given data set into 4 equal parts or in 3 quarters. So what is the purpose of using the quartiles here is we have to remove the outliers by just considering Q1 and Q3, so that if any value is either very low or extremely high will be omitted, and we will get a range that is considerable, that is reliable, that is you can say that range that is not misleading. So if even in your data set you get an outlier, then it will not be a problem for you, because we are going to get what? We are going to get the middle portion of the data. Which portion? This portion in the interquartile range. This is IQR. So once we will subtract Q3 from Q1, we will get the range of the data in between these two quarters or in these 2 quartiles. So this is the basic concept behind the quartile. Let's see how we can find the interquartile range if we are given with a data set, and what is the method of finding it. Let's have an example. Here we have an example. Here we have a data set. This data set is already arranged. You have to arrange the data set before finding the interquartile range. So it is already arranged. So you can see here that here we have an outlier that is 80. Now let's see how interquartile range will be helpful to get rid of this outlier, so that we can easily find the range of this data set. So first, the first thing here is first thing is to arrange the data. Secondly, you have to find the median. First we will see what is the count of this data set. So here n is equals to 7. So as n is equals to 7, then the median can be easily found here, as 3 values are here and 3 values are on the left and 3 values are on the right. The central value is the median. This is the median, or Q2. You can also say that this is the second quartile, but we don't need the value of Q2. We need the value of Q3 and Q1. So for Q1, we have to see the left side, the values at the left side. That is 246. We have to find the central value here for finding Q1. So here in the first quartile, this is the central value and this is called Q1. And in the third quartile, we have to find the central value, that is here it is 15. This is the Q3. So this is the simplest method of finding IQR, and IQR will be here. IQR is equals to, you just need to subtract Q3 from the Q1, that is 15 minus 4 is equals to 11. So this means that the interquartile range is 11. So here this outlier 80 has not affected the range of the given data set. So this is the basic purpose of the interquartile range. I'll give you another thing as well, the formula that you can use to find Q1, Q2 and Q3. For Q1, the formula that you can use is just to divide n by 4. 4 is for the quarter. So n is here the n was 7. So 7 divided by 4 is equals to 1.75, and you just need to round it off, it's 2. It means the value at the second position from the left will be the value of Q1. So it's 2. So if we move from left, 4 is at the 2. So it means 4 is the value of Q1. So this is basically telling you the location of the Q1. This is not the value of the Q1. This is the location of the Q1. And you have to pick the value from the given data set. Then we have the formula for Q2. For Q2, you just need to divide it by 2 as it is halfway of the whole data set. So n divided by 2 is equals to 7 divided by 2 is equals to 3.5, or if we round it off, we will get 4. So at Q2 will be at the 4th location in the given data set. So it is the same, that is 8. Q2 is 8. So then we have for the Q3, Q3 will be 3n by 4. N is the total count of the data set. So 3 multiplied by n is 7. 7 is 21 divided by 4 is equals to 5.25. That will be equals to, if you round it off, you will get 6. So the next value is at the 6th location, that is Q3 is at the 6th location. So keep this in mind. If you get a value that is in that is not a whole number, so and you have a decimal value with it, you just need to do what is, so you just need to round it off to get the value for the Q3. So these were the two different methods to find the interquartile range. Keep this in mind, that interquartile range means, as its name indicates, inter is between the quartiles. Which two quartiles? Q1 and Q3. So once you will get the Q1 and Q3, you can easily find the interquartile range. And keep this in mind here, that the main purpose of interquartile range is to get rid of the outliers, the misleading value of the range due to the outliers that we have seen in finding the range, the simple range. So interquartile range helps in such a way. So hope so today's lecture will be helpful for you to clear your concept regarding quartiles and the interquartile range. That's all from today's lecture. Thank you.